Hello guys, so in today's tutorial guys we'll be discussing about zero area network. So this is our topology, this is our new network. We will going to configure the open short path first using the area 0 network. So this is an area 0 network. So there's different networks. We can have an area 1, area 2 up to maximum of around 4 million area networks within a topology. So in today's tutorial we'll be going to discuss how we can configure this topology using the OSPF network or OSPF dynamic protocol. So let's go ahead and try to configure these routers so that each PC within the topology or within the area 0 network will be able to communicate with each one. So without further ado, let's proceed. So this is the eNSP that we are talking about. This is our area 0 network, as you can see. So I have already assigned some IP addresses within this PC so that we can save time. At least you can use at least the minimum little amount of time. There's no need of start from scratch building this topology. As you know, I have made some previous videos on how you can create topology, how you can assign IP addresses to these PCs. So the only thing we'll do, we'll configure our router using their different interface, and the next thing then we'll configure our OSPF dynamic protocol. So right now let's go ahead and configure our interfaces in each router. Then after that I will now configure the OSPF. So as I said before, I have already assigned IP addresses in each PC. So you can go ahead and check. If you check the basic configuration, here I show that I have already assigned the IP addresses. So each PC has its unique IP addresses. So in each PC I've already assigned it so that we can save time. So each PC is now being configured with that IP address. So let's go ahead and start with this router. So as usual, system view, then we do system name. Let's call it router 1. And let's check this interface. We are configure this interface, which is Giga Ethernet 0001. So we'll go ahead and write interface. Then it's Giga 0/0/0/1. Then the IP address for this is 192.168.0.1. It's within the .0.1 network. So this is the network that this router is within. Then with a subnet mask of 24. Wrong parameter at this position. Sorry, I have an error. This one, yeah, so should be that one exactly. That should work. So the next thing now, let's configure this. Let's configure this interface here. So we'll go ahead with interface 00. Then the IP addresses, it will be 1.1, 1.1. It's 1.2. 1.2 this interface. I click enter. So now we have configured this interface. Let's do the same for this one. So we'll do the same here. System name. Let's call it router 2. Now we want to configure this interface. We want to configure this interface here. So let's go ahead and interface giga ethernet 0/0/0, this one here, and then the IP address is 192.168.4. It's 4.2, subnet mask of 24. Let's go ahead and do for this interface also. So we go with quit, go with interface 0/1. The IP address is within 5.1. It's within 5.1. Click enter. Now we are done with that. Let's come here. Also configure this system name. Let's call it router 3. So it is within this interface. Let's start with this one, giga ethernet 00. So we'll go with interface giga ethernet 0/0/0. The IP address is 192.168. It's within .1 network. As you can see, it's within the .1 network, and then our interface here is .1. Subnet mask of 24. Let's do the same for this interface, giga ethernet 001. So giga ethernet 001, it's within the network. It's within the network 4, interface.3. Click enter. Then let's do the same for this giga ethernet 002. So quit interface 2 with IP address of, it's within the .2 network, then .2. And we are done with that also. Let's come here and configure system name. We call it router 4. Let's configure this interface also. Let's configure giga ethernet 001. So interface giga ethernet 0/0/1 with an IP address of 192.168. It's within the .3 network, .3.1 with a subnet mask of 24. So let's do the same for this interface, giga ethernet 00 within the .2 network. So I'll go ahead and quit. Go to interface 00 with an IP address of within the .2 network .3, and we are good to go. So right now we have finished configure the interfaces within each router. So if I try to pin this interface here, this gateway at this .1 network, it will pin. So let's try and do that. So if we try to pin the 1.2 network, it's pinning. So the next thing we should do, we want to communicate with these subnets here. So we want to communicate this subnet within this area 0 network. So if you can see, if now maybe if I try to pin, let's say this interface here, the .1.1 network, if I try to pin that, it will have a request timeout. This is because this router here is not aware of this router here is not aware of this router. And the same here, if I try to pin anything outside this interface, it will not ping it. The same here. So the next thing we need to do is we want to assign the OSPF, which we call it the open short path first. This is a dynamic protocol that each router will find a path or a shortest path possible to reach each router within the network. So we're going to configure each router with a router ID of each one has a router ID that is will be recognized within the network. So we'll go ahead and assign the OSPF dynamic protocol so that we will be able to ping any router within the area 0 network. So let's start by configure this one. So we'll go ahead and configure this one. So we'll come here and quit. So we'll start by assigning the router ID. So it will be OSPF 1. We are using 1 as the process. Then with the router ID, just go and write router ID so 1.1.1.1. Click enter. Then we are within the area 0 network. We are within the area 0 network. So it's good to specify the area that this topology is working on. So it's working within the area 0. So we'll specify our topology as area 0. Now within the area 0 we need to assign the network. So we'll assign this network, this 0.0 network, and also we'll assign this network here. Let's start by this 0.0 network. So we'll add a network which is 192.168.0.0. Then here the mask. The mask meaning is that we want to tell this router or this network that there might be possible there might be as many as there might be as many as possible PCs within this subnet. So we want to add a subnet mask of 0.0.0.0.255. This means that the 255 here means that there might be possible 256 IP addresses that can be assigned within this router. So if we use this 0.0.0.255, we are telling this OSPF that there might be possible existence of as many IP addresses within this router. So that's why we are using the 255, indicating that it is not only these two router or not only one router. So it will not supposed to be restricted. It's not like this network. This network will have to assign the mask of 0.0.0.0. This is because we only have this network that will exist between these routers. So there's no need of having multiple IP addresses within this network, because this network is only for connection between this port to this port. So that's why we are using the 0.0.0255 as a mask. So hit enter. So the next thing we'll do, we'll go ahead and also assign the network, the same network, but this time we will change this mask to 0.0.0. As I said before, 0.0.0 mean it is strictly this because we only have this gateway here, this interface here of 1.2 network that we'll be using for routing or for processing this data that will be requesting from any of this PC within this network. Therefore we have to use this strictly because there's no any other possible IP addresses that will exist from here apart from this one. So we'll go ahead and do that for this interface, and we will change our interface now to be within 1.2. 1.2, we are assigning this interface. We are strictly minimize the IP addresses using 0.0.0.0 mask. subnet mask. So then you click enter and we are good to go. So the next thing we'll do, let's come within this one again and do the same. So with this one again, we'll go and let's quit. Let's go with OSPF 1 with a router ID. It's 4.4.4. It's within the area 0. So it's within the area 0, and within the area 0, let's add a network. Let's add a network of 192.168. This is the network that we want to add. We want to add this network, so we'll add the 5.0 network. And since we know that there might exist some possible, not only these two PC but a lot of PC or IP addresses that might be used within this router, therefore we'll need to avoid strictly, we have to use an available mask that will not strictly minimize the rate at which this IP address will be available within this router. So we'll use the 0.0.0.255. As I said before, this indicate the 255 indicate there are possible 256 IP addresses that can be used within this router. So once we're done with that, just click enter. And now let's go and assign this interface here within the .4 network. But at this point, we'll have to use a strictly mask, meaning that there's really only this .4.2 IP address that will be used within this network. So let's go ahead and do that. So we'll do that and we'll strictly minimize. So .0, and then let's change our interface, which is now 4.2. Once done with that, hit that tab, enter, and we are good to go. So let's do the same for this one, and then we'll get back to this main one. So let's go ahead and do for this one again. So just quit. Then let's talk about OSPF with the process 1, then router ID of it's within the root of 3.3.3.3. hit enter. It's within the area 0. Now within the area 0, we'll need to assign the network. Let's go and assign the network. Go ahead and assign the network 192.168.3.0. Then we'll use the subnet mask of 0.0.0.255. 192, it's okay. Let's go ahead and also do the same for this one. .0. So let's go ahead and do that. And now we'll talk about this interface here. It's within 2.3 network. So we'll do the same here. We'll do the same. It's like, seems like it has submitted itself, but don't mind. We'll just undo it. Just undo that way. Then we'll go ahead and assign this is 2. It's within 2. It's within 2.3, and then go ahead and Let's see. Then let's now go ahead and do for this main one here. So let's start by system, then you go with OSPF processes one router ID, which is basically 2.2.2.2. It's within the area, 0. Within the area 0, we having a network of 192.168. Let's start with this one, 192.168.1.1, and it will be strictly, you'll use a strictly mask because they will only, this one will be the only this part that will be used. So hit enter and do the same for this 4.3. so we'll be using the same for 4.3 and also hit enter. Let's go and use the same again for this one also, the .2 here within the 2.0 network. So we'll use the same, but for 2.3, this one 2.2, and we also int. So let's now see. And now, so the next thing we'll do, so that if we check if we have truly configure our OSPF before pinning, it's good even to check. Let's check our OSPF routing table and see if we were able to assign the OSPF dynamic protocol within our router. So go ahead and display. Let's now display our OSPF. It's peer brief. So write this command if you want to view your OSPF table. As you can see, we have, you can see our state. If our state is full, meaning we have successful assign or configure our OSPF within this IP router. So as you can see, this is our router's ID. If you check the router ID 1.1.1, we have successful assigned the OSPF protocol, the same for 3.3.3.3 and the 4.4.4. so let's go ahead and check for these routers also. It's good to confirm. So let's go just ahead and do for the same. So let's display the OSPF. So OSPF pair brief. Also, you can see the state is full for 2.2.2. This is our 2.2.2 root ID here. Oh, it's aware of this neighbor. It's having the router ID for this neighbor. Our 1.1.1 router ID is having, or it's aware of this neighbor here. So the same here, this one also should have 2.2.2 as the neighbor. It should be aware of its neighbor. So let's do the same and check display OSPF router OSPF peer brief. It should also have a 2.2.2, meaning it's aware. This topology, each router is aware of each one within this topology. As you can see here, this router is also aware of this .1 router. It's aware of .2.33 network, and also it's aware of .4.4. Also, this one is aware of .2.2. So the next thing we go, let's now try and pinging. We will now try to ping. Let's try to pin this interface here 1.1 and see if we can able to get reply this time. So you can see this time we are able to get reply, meaning our OSPF protocol dynamic configuration has been enabled. This means that this router is can able now to pin anything within this area network. So let's go ahead and try to pin this interface here at this point, which is within the 2.2 network. So let's go ahead and pin 2.2 and try to see if you can get reply. Well and good, we are still able to get reply. So the thing is that OSPF, it's kinda much easy or very easy to configure as compared to the static IP routine. As you can visit, or you can, if you have watched my previous videos on how to configure the topology using the static routine or using the static routine protocol, we were supposed to configure each router manually to ensure that this router is aware of this, and also it having the destination address and such things like that. But this one is, we only need to assign the OSPF, or we call it the open short path, first in each router, so, and with a specific router ID, so that we can know that this OSPF belong to this and this here, so that each neighbor or each router, it should know its neighbor, who its neighbor. So you can see our 2.2.2 router ID is aware of this neighbor, aware of this and this, meaning it, if we try to do anything, or we try to send some packets or receiving, it will not be able to configure or unable to recognize this, because within the OSPF table they have these neighbors. So that is it. So let's try to do anything. Okay, let's try to pin this PC within this one. So we'll go ahead and pin this within the 3.2 network. Let's try pinning that and see if we are able to reach that point. Let's try to pin. Also, you can see we are able to get feedback, meaning that this area, or this router within these PCs within this router are they are now able to communicate with any PC within a different router or within the same area network. So let's go ahead and do for this one and try to pin anything within this area here, and let's try to pin the PC6 within the 5.6 network. So let's go ahead and do so. So ping, let's try to pin 192.168.5.2 network and see if you're able to get replies. As you can see, we're also able to get reply, meaning we have successfully configured our OSPF on this area 0 network. So this was for today, guys. I really appreciate for your time, but on the next video we'll configure a large network within different area. We try to create a different area whereby we'll try to communicate within a different, or within a large network, whereby we'll having different areas. We can have an area 1, area 2, up to area 4. So the next video will entail how we'll be able to configure these areas and how we'll be able to communicate within each area. Area 1 should be able to communicate with area 0, as well as area 5 should be able to communicate with area 1 as well as area 0. So this is what we'll be doing for the next video. So we'll try to save time, we'll try to configure. So I will try to assign the IP addresses before resuming this video, so that we can save time. The only thing we try to do, we'll try to configure the OSPF with you. So that's the only thing that I will be left behind, so that we will go ahead and do it together. But assigning IP addresses, creating that topology is something that you can do on your side by just look at the topology and try to copy the same it is. Try to copy the IP addresses. You can also decide to create yours. So The key here, or the key concept, is how we will be able to configure this topology or that network using the OSPF dynamic protocol. So thanks guys for your time. Hope to see you in the next video. Please guys, remember to subscribe to my channel. I truly appreciate for the next video like this. So subscribe, and thanks for your time. See you in the next video. It's Kolo again.